A big thank you to the Talk Python team who sponsor this episode of the podcast. If you want to get better at Python, now is an excellent time to take an online course. Whether you are just learning Python to delve into great topics like artificial intelligence, or you need to go deep into things like APIs and async, my friends at Talk Python Training have a top-notch course for you. Visit talkpython.fm/mind to find your next level and get a 10% discount. Also a big thank you to all my Patreons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast. In this podcast we cover topics such as engineering, artificial intelligence, neuroscience and other interesting topics to educate, inspire and engineer people's minds all around the world. I'm your host Joseph, and for this episode of the podcast I'm very happy to welcome Milad Mafi. Milad was born in Hanover and studied mechanical engineering. When he was 14 years old, he used Computational Fluid Dynamics to investigate how overtaking manoeuvres in Formula 1 are aggravated due to turbulence. With that, he won the contest for young scientists called Jugend forscht. After that, he started consulting businesses like Volkswagen, Airbus, CarboTech in the field of computational fluid dynamics and aerodynamics, and later he focused on innovation management. His last station before founding his startup Modum was the cloud-based simulation provider SimScale. Modum is a DTC bespoke dress shoe brand. The proprietary 3D scan and 3D printing technology allow producing bespoke shoes on any standard industrial production line on demand, and at the same cost as mass-produced, ready-to-wear shoes. And now, ladies and gentlemen, here is my conversation with Milad Mafi. Milad, it's a pleasure to have you on my podcast. So to have an old colleague from SimScale on my show is really a pleasure. What I want to start with is, as always, can you give an introduction to yourself, what you do and what you studied and so on?
Yes, for sure. Thank you, Yusuf, very much also for being your guest today. My name is Milad. I'm 28 years old. I've studied mechanical engineering in Hanover. And I originally started my career in simulation engineering, working first of all as a user. Later I switched to a more marketing and sales-orientated role or different roles. And today I'm the co-founder of Modum, the world's first direct-to-consumer brand for bespoke shoes.
Sounds good. Well, you talked about simulation. Can you walk us a little bit through your early days of simulation, what you did when it comes to simulation?
Yes, for sure. Actually, my journey into the world of simulation started as a hobby. I was a huge fan of racing and in particular Formula 1 since my childhood. And in contrast to most of the other fans, I was not mainly interested in the drivers. I was also interested in the drivers as well, but really my main focus and interest was on the technical side. I was fascinated by the speed of the cars, and also by the design and the sound. And so I read everything I could get into my hands about F1 technology. And back then, it was a little bit different because, internet was there, but there were no dedicated F1 websites or articles on Wikipedia, which you will find today where a lot of stuff is explained. So I usually used every book I could get into my hand. There were a lot of stuff in the public library. And then someday I read an article in the F1 Racing magazine about the new cluster of the Sauber F1 team. And then the first time in this article, I read about CFD. And before reading this article, I already played a little bit around with CAD tools. I got my hand on a copy of Solid Dash Educational. So I started to model like front wings or other parts. And then I saw, that would be pretty cool if I would be able to design my own car. And it seems like that the CFD was the final part which was missing. But it was not possible at the time to get a hands on a license. It was also, everything was a little bit different. It's just 15 years ago, but back then there were no open source tools. I'm not sure if Open Foam was already released, but it was not accessible.
Mm-hmm.
And some months after, in F1, they started a big discussion about changing the rules because, as you know, these cars have a lot of wings and downforce generating elements. And what a lot of people don't know is that actually what is called slipstream in F1 is not in any case a good thing. For sure, if you're on a straight, it's great, but F1 cars are particularly fast when it comes to cornering. And therefore, overtaking was become very difficult back then because the cars were generating a lot of downforce, a lot of turbulences, or how it's called, dirty air. And what the sports governing bodies then proposed was to change the design and to split the rear wing of the cars, which looks really ugly. Mm-hmm. And I saw, maybe that's a good chance to do something and to get involved with the sports, because back then I was 13 or 14 and it was really impossible to get in touch with these guys. So I just grabbed my phone after school and called that Fluent, which is now part of ANSYS. And somehow I managed that the guy at the reception connected me with the sales manager of ANSYS for automotive. And I asked him if I can have a test license. And he somehow directly spotted that I can't be a real customer, maybe because my voice was not sounding very mature. And so we started to talk and I explained to him what I want to do. And 2 or 3 weeks later, they invited me to come to their office, which is in Darmstadt. And I got a ANSYS or Fluent training, and they sponsored me with free software. And that's how I get started with CFD. And then I was doing a kind of youth research project and investigated with the help of CFD why overtaking is so difficult in F1 and which change to the regulation could promote overtaking.
Mm-hmm. So you also won this German contest for young scientists called Jugend forscht. Can you explain what it was about? And
it was basically the same project. Mm-hmm. So my project was in study where I first of all created a generic model of an F1 car. Then I simulated this model, an isolated car, different scenarios like 2 cars driving side by side or 1 car behind the other. And in the first part of my work, I analyzed why overtaking is so difficult today, mm-hmm. and found out or showed that a lot of parts of the car are generating wake, and that inside this wake, if you're following the car, your aerodynamics or your bodywork will not generate the downforce you need, because that's from a physical point of view, the total pressure is very low in the wake. And if the total pressure is low, you have less kinetic energy, which can be converted by the wings and the underbody to downforce. And based on that research, I supposed new regulations, new technical regulations with a different design, which was mainly about, instead of splitting this wing, to keep the wing geometry, but to have the wing much higher above the ground plane. Mm-hmm. And that way I wanted to stop this interaction between the rear wing and the floor of the car. Because what is very funny is that most of the turbulences are not generated by one part itself, but by the interaction of vortices of different parts. For example, the front wing end plates are generating vortices, and these vortices are used then under the car to seal the underfloor of the car, to similar to end plates on a wing. But when these vortices leave the car, they expand very quickly and generate a lot of dirty air, and it's like an amplification. And so that was the idea of my project and what I presented.
Got it. Did you get your head around CFD in particular very fast, or did you have the mentors from Fluent assisting you, especially with the trainings you mentioned?
Actually, it was really a mess at the beginning. I was interested in math, and also I would say I was good in math and physics and some basic stuff about calculus. But when I started, they had a one-day training for me where I was sitting together with, I think today you would call him an application engineer. But to be honest, the first year, I worked 3 years on this project, and the first year, I actually didn't get anything really done. I had some nice, colorful pictures, but most of the time the results were pure crap, which was obviously related at the beginning to my lack of understanding, and not mainly the physical stuff, but also a lot about the math, and routine was also missing. And a lot of times I actually was about to, does not make fun and I want to stop it, but I didn't, because just after I started to work on this project, new opportunities came up, and I met guys at Microsoft and they started to sponsor me. And then someday I met a guy from F1 and I got in touch with them. And this was what's motivating me. Like, you just have to keep your head down and you will find a solution. And after the 3 days, back then I would say I still hadn't any clue really about CFD, but I knew enough to create precise models specifically for my application. And I learned it on the job, but it was a real struggle. And that was actually one of the reasons why I wanted to do stuff different when I joined SimScale and took care for the training and webinars, because what hadn't really changed in the last 15 years is that a lot of tutorials are just like click this, click that. Yeah. And I can remember I started with this Fluent, they gave me like this 2 standard training folders every Fluent customer gets. Mm-hmm. And the examples, it's easy to follow them, but it does not really help you with your own problem. I think the meshing tutorial was something like a cycle for separating, stuff. And the tutorial explained exactly what you need to know to do to mesh that geometry, but it didn't explain how to clean a geometry, and also not what it's really about if you want to do a mesh for a case where you don't know anything about the actual solution. And but they supported me a lot, and I also so I could call them every time I had a problem. And also, whenever I needed a training, I was able to join one of their existing trainings. And somehow I, in the end, managed my way through the software. And and at the end, it made fun. After the second year, it really started to make fun for the first time, doing the simulation itself. Post-processing was fun all the time. Mm-hmm. But once you start to understand why things are not working, or when you have this confidence that, okay, it's not working, but I have a plan, I will do this, that, and this, and you really know that somehow you will find a solution. That's when it started to make fun for me, debugging CFD.
Mm-hmm. Got it. You obviously have been a trainer and holding a lot of webinars when you worked at SimScale. Do you think it was easier for you to hold the webinars because you had that experience? You had to go through the pain of really learning CFD by trial and error. Was it easier for you to then bring the message to the audience because you went through all of this?
I think absolutely. It was first of all a big motivation and also a guideline, because every time I was like thinking back how I was feeling when I started to do CFD, and I knew how it should be done differently. Mm. And therefore, I think it helped a lot. What was very funny is that a lot of times I really wished, if I could just like delete some of the knowledge out of my brain for a day, because I really also started to understand why those people at ANSYS were doing their learning materials the way they did it. And I think that's the biggest challenge. If you train someone and you are very experienced, it's really hard to decide what is important, what is not important, and what you can expect from them to know. And because when I really started with the first trainings or the first webinars, we really started to, what is the equation like that. And at some point we realized that was maybe too much. And in the end, and I think that's really the most important point when you do training, is to target it to your audience. if you do something very application specific, for example, when I also did some private trainings for customers, and what worked with them every time was really to center everything around the applications. For example, we had a customer we had a lot of customers which were doing AEC in the end. And usually these guys are architects and they have no idea about their engineering. Yeah. I mean, in Germany, I think their degree is an engineering degree, and they also learn a lot about, basic physical stuff, but not in a way an engineer learns it. They also work very lot with spreadsheets, and a friend of mine is an architect, and he says the only part of his job where he needs math usually is to create the invoice. So and there, for example, what we did was like bringing it back to their physical perspective, because they are not thinking in momentum and pressure and equations, but more hands-on stuff like hot air rises up and stuff like that. And that worked very good. And on the other hand, when we had these more general trainings like the CFD masterclass, or what we did with Formula Student, there we tried to get people really at the beginning. And a big part of the work was actually to create personas and to have good assumptions about what they know and what they're interested in.
Mm-hmm. Sounds good. Anything you want to say when you think back to SimScale, to the good old SimScale times? Anything about your colleagues, about the work ethic, the work experience at SimScale? What would you say? Of course, things have changed. We have become a lot more people now. But anything that you kept in mind about SimScale, what would you say?
A lot of things. I mean, when I joined SimScale, I was working mainly in the automotive industry, which is, I would say, the exactly opposite of a startup environment. Not only because these companies are big, but also the way they think. They're thinking in very long processes, and a lot of politics around, especially motorsports. Mm-hmm. And when I joined SimScale, first it was like a little shock at the beginning, because the computer I was using was a 6 or 7 year old ThinkPad. And I first thought, okay, they just hide a lot of people, and it's maybe the only laptop they have right now. But then I understood, wow, everybody, including the founders, are using these old laptops, and it was completely different. It was really about the work and not about making things more shiny than they used to be. Mm-hmm. But I really get used to it very fast. And actually a lot of stuff about how to manage resources I learned at SimScale helped me a lot now with my own venture. But I think the most important thing at SimScale and the most inspiring thing was really having these great people around. I mean, it was really funny, especially at the end. I think we had hundreds of applications for an intern role. And that really shows that people really quickly understand that the bar is very high at SimScale. And I just met exceptional people. I mean, starting from the founders, but also my colleagues. And I learned a lot of stuff. And I think before I never worked so closely with people through all departments, and that actually didn't change over the time. I mean, I left SimScale in December 2018, mm-hmm. and I think back then they were already 80 people or something like that. So it was already a big company, and I didn't knew anybody because after 2015 I worked remotely only. I was in the office for 1.5 years, but then I moved back to Hanover. But still, whenever I had a project where I needed to work with someone else, it could be from the accounting department, sales, especially engineering. It was such a great and, goal-orientated way to work together. And that's was also one of the reasons why I decided to start my own venture, because really at SimScale I saw that how much fun it is to build something up and let's say start from scratch and change things. And obviously being at SimScale for 3 years had a big impact on my professional life.
Mm-hmm. Very excellent. Sounds great and very inspirational. Before we get to Modum, in a minute, we'll talk about the consulting businesses to be precise, what you did during your studies at Volkswagen, Airbus, and so on. Can you explain what you did there and how you did it?
Yeah, for sure. Actually, it started all at the end of this youth research project, because back then, these companies were not also providing the software, but also paid me money at the beginning, like for travel costs and all the stuff I needed. And for that reason, I needed to set up a consulting business or to set up a company, because they needed an invoice. Mm-hmm. And then after this youth research stuff, they asked me if I would still be willing to do a follow-up project with them, or especially representing these companies on conferences, because back then I was doing a lot of talks on conferences. And that way I got into consulting. And when I was at school, I get approached by a first company in Hanover, an engineering company, which had a project where they needed CFD, and they didn't have anyone who was doing simulation. I think back then, simulation was also not so available, especially to small companies like today. So I started there, and there I met someone from an Austrian company, CarboTech, which was back then a leading manufacturer for composite parts. Like they were doing the monocoques for the Porsche Carrera GT and for some F1 teams were supplying stuff. And we got in touch, and then I visited him in Salzburg where the company was headed. And then I had an idea for developing a system for active flow control on race cars. And actually, I just wanted to get them on board as a supplier. And we ended up in that meeting with doing it together, and that they would pay me, and in return, if we are successful and are able to sell it, that we will split up the revenues. And that was my first real consulting project. I started it at the end of high school and finished it during my first semester. Mm-hmm. And again, there I met other people. And then the next big thing was that I got approached by, what is it called, these companies? Those companies which are looking for employees and stuff like that. Yeah. And back then, Volkswagen started the World Rally Chip program, like Formula One for rally. And they just fired their head of CFD, or the person who was supposed to build up the process, and they quickly needed someone who was able to replace that person. And I just had finished this project with CarboTech, and I actually wanted to focus more on university in the second semester. But then I got a call on Friday, and they explained me about the project. It's a big car manufacturer. It's about motorsports, and they need someone who can start quickly and build up the CFD process, because the car was half finished, but the CFD process was not working at all. And then I thought about it, and I mean, it was good money. And also I was in love with motorsports. And so I tried to give it a chance and started 2 or 3 weeks later. And what I actually did, I think it was around 9 months, was building up a whole process so that whenever there was a design change in the engineering department or design department, we were able to very precisely predict overnight how these changes will affect the aerodynamics and HVAC and cooling of the car. And And that was actually how I got in touch with open source CFD or OpenFOAM, because before I was using only Fluent, and I also didn't had I was sponsored by Microsoft, so I didn't had a good opinion about open source software. And for me, it was just like cheap solution, not a good solution. But there I had to use OpenFOAM because back then Volkswagen, the whole group, had a big project with a British consultancy, and they tried to switch completely from commercial CFD to OpenFOAM. I think the idea was to save money, actually, on the one hand, because these automotive companies, they pay a lot for CFD licenses. I mean, they usually have clusters, and even 2010, they were using like 500,000 cores for a simulation. And as you know, with on-premise software, you have to pay or buy a license for every core. And so really the idea was, and I think that was really smart, instead of, I don't know, spending $3 million a year for a software vendor, to take OpenFOAM and to build your own custom CFD software, especially since OpenFOAM was not only easy to customize because it was open source, but also because it was very easy to automate. I mean, all the other tools like ANSYS or StarCD, it was possible to do scripting and stuff like that. But back then, OpenFOAM was the only tool which has a reliable bottom-up meshing approach, where you don't need to mesh the surfaces, but you have a background mesh and snap it and project it, which make automation very easy in the environment of automotive, because you usually have the same topology of your models every time. Maybe the surface or the shape changes, but a race car still has a body, a rear wing, a front wing, a floor, radiators, and it was easy to script it. And so I had to work with OpenFOAM, and I really loved it just after the first week, because once you set it up, it worked. And you could just change the geometry. And yeah, that was like the first real big project I did for 9 months. And after that, I again, because I had to took a half year off from university because it was really a full-time job. Yeah, and after that, I did other projects, not only in the field of CFD, but at Airbus, for example. I did a lot of stuff regarding innovation management and how you can use these big facilities and plants they have in other industries. And so I had my own consulting business during my studies. And actually, through one of these consulting businesses, I was also, after I left this Volkswagen job, I worked at ESI, which back then bought OpenFOAM. So OpenFOAM, the software is open source, but the trademark is owned by ESI. And there I was, which was also very exciting, like part of the original team, which was integrating the OpenFOAM brand and technology into the existing ecosystem of ESI. But in the end, it didn't really work, not because the software was not good, but it was really a challenge, to integrate open source software and the community into a commercial environment of a private company. And when I realized that, okay, it won't really work the way I imagined, then I met David. And I never saw about what he was telling me, like we do cloud-based CFD, and I knew what cloud-based CFD is, but when he told me like it's in the web browser, he really got me. And then through my last consulting job, which was also like a long-term thing, 2 years at ESI, then I changed my job and started to work at SimScale.
Okay, very interesting journey. So if anybody's listening now and feels motivated by your story or journey, of obviously doing consulting and doing studies on the side, so to speak, is quite time intense. Do you have any tips for students who want to go on the same path as you? like in terms of time management? And is it possible, or is it also a matter of priority?
I was not really good at time management back then. I became better through that job spot. At the beginning, so I'm not the best advisor maybe for time management, but first of all, I think it depends. You should really make sure that you finish your studies and you finish them in time. I think it isn't a shame if you need like 1 semester or 2 more, but you shouldn't end up with studying 25 semesters or 20 semesters just for doing some consulting business. And I think if you want to get started, there are different paths. If you want to do something in a technical field, I think it's really important to find your niche. And in the end, it's a chicken and egg problem, because in order to get jobs, you need to have kind of track record, and you mainly also need a network. But without you can't get a job without experience. And I was in the lucky situation through this research stuff I did that I had a network and some reputation. However, I think it's not necessary. And I mean, for example, if you start to study and you get interested in something particular, I think today you have a lot of great opportunities, stuff like you are doing, like setting up a YouTube channel, creating a blog, and show a track record somehow on that way. Or also, and this is maybe something actually every student can do. I mean, you have to write a thesis. And for a lot of students, they just take a thesis which is on the, which is published, finished thesis, which is published on the website of the department, and which looks like an easy job. But especially a thesis is a great chance, because usually if you choose a good topic, you will not only get specialized in a certain area, but you also have usually the possibility, if you do a really good job, to publish it. And this is also, I think, a good way to get reputation and also to meet some people. And but I really think the most important point is that you need to invest first your time, because let's say, I think today every student who wants to do it can do a CFD business. It's actually, I think, a pretty good time, because the tools are very accessible. I mean, you can actually get started with SimScale, and you can learn it from scratch for free. And once you got your first job, you can start with the standard subscription, and I'm pretty sure that you will have have it paid back, like with your first job. And also accessing customers is much easier today, especially with small companies, with the small tooling company around, which needs someone who can help them to improve the cooling of their machining booth or stuff like that. And I think you just need to invest some of your own time. Obviously, you won't be able to do consulting after having followed or finished one tutorial. But if you start to gain knowledge in a certain area and you're good, I think that's everything you need actually to get started. And I never tried it myself, but there are all sort of platforms like Upwork and stuff like that, where it's much easier today to find someone. And obviously, CFD today is very popular, which is good because there is a demand. But I'm pretty sure there are other things right now which are not as accessible as CFD, and where it's even might easier to get in with less competition.
Get it.
For example, I mean, I have no idea of machine learning, but if I'm on LinkedIn every day, I see people or companies which are like really look desperate and need someone who did the job. And actually, I got my first job because they were so desperate because they were not able to find the engineer. And I think this is something which, with these newer technologies, can work. And once you got your first job, it will be so much easier to get your second job. And yeah, to get started, it's the most difficult thing, like with all things in life.
Yeah, that's great impetus from you here, Milad. Of course, we also want to talk about your company, Modum. You mentioned it earlier on when you introduced yourself. Can you explain what is Modum and who are your target customers and what you actually do?
Yeah, for sure. So Modum is the world's first direct-to-consumer bespoke dress shoe brand. And to understand what we are doing, because we are focusing on a very special segment of customers, let's maybe go a step back. So what are bespoke shoes? Whenever you go into a store to buy your shoes, this is what we call ready-to-wear shoes. So these are pre-designed and pre-manufactured shoes which are sold or sell in shoe sizes. And there are also bespoke shoes. And bespoke shoes, in contrast, they are not pre-produced based on shoe sizes, but they are, let's say, designed and made individually for each customer. And it's actually a very old craft, similar to bespoke suits. So like in Germany, in bigger cities like Munich, there is still a bespoke shoemaker. You go into his workshop, he will measure your feet using a ruler and measuring tape, build two kind of molds, which he uses then based on your measurements for every foot. And then based on this shoe last, that's how these molds are called, he will build your own shoe, which has a perfect fit, the exact design you want. And it's really the pinnacle of shoemaking. And bespoke shoes are very expensive today. Like in Germany, you easily pay for your pair of $2,000 to $3,000 because they are completely handmade. And until today, it was not possible to manufacture them on an industrial scale. And we have developed a technology which allows us to manufacture bespoke shoes the first time on every standard industrial production line. So we don't need to touch the factory, we don't need to touch the machines. And we have like digitalized the whole process, starting from measuring your feet, designing your shoe. For this, we've developed a smartphone app. And then we have a system which is based on artificial intelligence and which is fully automatically designing the shoe, all production data you need, and provide them in a way to the factory that they can manufacture the shoe and they even don't notice it's a bespoke shoe. For them, it's like manufacturing a shoe from the shelf hundreds of times.
Get it. Does it work with an app on your smartphone?
Yeah, exactly. We have a smartphone app which you actually take 3 pictures of your feet on top of a sheet of paper. And from these 3 images, we can reconstruct a very precise 3D model of the feet and extract measurements. Then you have a kind of 3D configurator, which you maybe know from car companies, where you can like choose, I want this kind of tip shape, I want this kind of dress shoe, this color, this pattern, this kind of sole. And this data is then automatically processed by your software. And the customer gets his bespoke pair of shoes 3 to 4 weeks later by mail and at a price at which only shoes out of the shelf are available today. And now we are targeting actually people who are right now buying premium dress shoes. Maybe you heard it, welted shoes, so shoes which are not glued but welted and which can last up to 10, 15 years.
Yeah.
And for the first time with our technology, you get a bespoke pair of shoes for the same money.
Get it. You also mentioned artificial intelligence. Do you know how it is involved? Like what exactly do you do with AI?
Yeah. So basically, designing the shoe is really challenging because it's not like grading that you just say, okay, I need to scale it by 10%. Actually, you have more than 20 measurements, which can change independent for every person. So in order to, and this is very important, to be able to create these shoes or to build them on an industrial scale, we not only need to manufacture them on an industrial production line, but we need to avoid any manual work. So the design of the shoe needs to be done automatically. And for this, what we use in the end is it's an artificial intelligence which was trained with the knowledge of the bespoke shoemakers. Two of our founders are very well-known bespoke shoemakers. And this model or the system was trained on their knowledge and is automatically designing the last based on the inputs are the measurements and the output is the CAD geometry, and which is then processed through other steps to the production data.
That's super interesting. How much is simulation involved in this process? Is this only measuring, or how much is?
It's quite funny because I mean, when I left SimScale, one of the last things I can remember I said to Agatha back then was that I love simulation, but I'm somehow happy to never to get in touch again with that stuff because it was not frustrating. I mean, it was my passion a long time, but after 13 years, it was somehow not boring, but I wanted to do something new.
Yeah.
And so I started to do this shoe business. I had this idea for this bespoke shoe technology. And I thought, okay, you will have to deal with a lot of stuff, but the last thing you will ever use again probably is simulation.
Yeah.
And it came out in the end that now FEA simulation is a very important part of our process chain. And I will explain you why. I mean, we design, which makes sense, the shoe last. I sent you an image, maybe you can show it later that people get an idea what a shoe last is, but you have this mold, which is used to build the shoe. And in order to build this shoe, you need two things. You need a physical copy of the last, which is then like in the factory used at every machine, to get the leather around it and stuff like that. But you also need the leather, and this leather need to be cutted according to a very precise pattern, which is exactly the unfolded shape of the shoe.
Got it.
Because if it's like too small, you won't be able to get the leather around the shoe. And if it's too much material, you will have wrinkles. And this was one of the points which was really hard to automate because what in the shoe industry is done, and also really in the industry, not only by a shoemaker, but also if a company like Edward Green or Adidas is creating a model for a shoe which is manufactured thousands of times, they don't use CAD. They have a physical model of the shoe last, and then they put tape on it, and then they cut the tape and manually flat the tape. And that's how they unroll the surface, because as you might know, from a mathematical point of view, you can only unfold very simple objects like a tetrahedra, or if you have a hexahedra. Like if you want to unfold this object, like this is one surface, this is one surface, and then you can like unfold it. But when something has a free-form surface, it's not possible anymore. So what we did then is, because this was a real problem, because it really seemed like this is something which we cannot automate. We cannot like have a factory with 20 people which are manually like putting tape on the shoe last and removing it. And here's where CFD starts to play, FEA is starting to play an important role. because what we are doing now is that, and I hope it's not too technical, but I mean, it's a technical podcast.
Yeah.
As you know, and this is again related to simulation, there are two main concepts of representing a geometry on a computer. One is using a precise model, like having a NURBS model. And the other option is to have a discrete model, which is usually a mesh. And an analytic precise model, it's not possible to unflat the geometry. It's not possible. But when it's come to a mesh, it is possible because your mesh consists of regular elements. Mm-hmm. And so what we are doing now is that we mesh the surface of the shoe last. And then we have something like a pseudo FEA simulation where we are like minimizing the stress inside the material. And that way we can flat it. Mm-hmm. It's not 100% precise, but it's not important because it's much preciser than what the guys in the shoe factories and shoe workshops did 200 years with tape, with putting tape on a shoe last. And since the leather is has an elasticity, as long as it's precise enough, it's not a big deal. And the difference, for example, this area difference from between the flattened model and the real model is like less than 1%. And so we are using FEA to generate the custom pattern for the shoe for every customer. And this is a fully automated FEA process where the model, which was generated by the artificial intelligence, gets automatically meshed, got automatically simulated, and then the flattened shoe surface is automatically processed to a DXF file, which then is sent to the factory.
Oh, that's super interesting, Milad. I think a lot of people would be interested in this podcast because you explained it so well. To wrap things up, how can people get in touch with you, or where can they find Modum? I mean, obviously you have a website, but maybe you can give us a bit more information here.
Yes, for sure. I mean, first of all, I'm around on LinkedIn. And so if you want to reach out, just feel free to add me as a contact or to send a message. I also on our website, modum-shoes.com, there are all contact information in the case you want to reach out. And I think that's the two best ways to get in touch with me. And I'm happy to answer your questions if there is anything related to Modum or engineering and fashion, which is what we are doing and very interesting. Looking forward to hear from you.
Excellent, Milad. Thanks a lot for being part of this show and looking forward to hearing from you and seeing how Modum will do in the future.
Thank you very much, Youssef. It was a great pleasure being here with you. And I wish you a wonderful day and talk to you soon.
See ya.
Bye.